Okay. So far we have solved quadratics by the square roots. We have solved quadratics by factoring. But what happens if you can't factor it? It's not factorable. We no longer write prime. Okay, so if we have x squared minus 14x plus 16 equals 0. So if we were to look at this and create a product sum table, so the product sum, product would be 16, sum would be negative 14, 1 and 16, nope, it gives me either 15 or 17, 4 and 4, nope, 2 and 8, either gives me 10 or 6. So as of right now, this is not factorable. So we are going to do what is called completing the square. So what we are going to do is we are going to subtract 16 on both sides. Okay, then what we're going to do, remember we had those perfect trinomial squares. For example, if you had x squared plus 6x plus 9, this is a perfect square, so we would end up with x plus 3 and x plus 3, which would give me x plus 3, that quantity squared. So this should kind of look familiar from the vertex form. So this is what we are going to try to create. So what we're going to do is we are going to figure out what number would make this a perfect trinomial square. So let's go back to this. We need to figure out what number would I add to both sides that would make this a perfect square. So we're going to take our 14 and divide it by 2, which gives me a 7, and we are going to square that. So 7 squared equals 49. So I am going to add 49 to both sides. Remember, when we have a perfect trinomial square, whatever sign this is a sign that goes in there. 49, the square root of that is 7. And then 49 minus 16 gives me a 33. So I have the square root of x minus 7 squared equals 33. Just like what we did when we were solving by square roots, we want to get rid of this. So we are going to square root both sides. And what do you have to do if you add the square root sign? You have to add the plus or minus sign as well. So x minus 7 now equals plus or minus the square root of 33. We are still solving for x, so we are going to add 7 to both sides. Be careful with this. So x equals, you would write 7 plus or minus the square root of 33. Now that means absolutely nothing. So what you need to do is separate this and write it as two separate values. So you have 7 plus the square root of 33, or 7 minus the square root of 33. I never want to see what the square root of 33 is, because I don't really care. So in my calculator, if I do that, I end up with 7 plus, you do not need to write this down, a 5.74. So this would be 7 minus 5.74. And you would end up with 12.74, or 1.26. Now, these are rounded, so we would say that x is approximately equal to 12.74, or x is approximately equal to 1.26. to 6. So in your homework, I really don't care if you skip this step entirely and just put this into your calculator and then jump down and give me these two values. I am fine with that. So what this means is that your parabola or your quadratic does not intersect at two nice neat spots. It intersects at almost 13 and it intersects at a little more than 1. So those are my solutions to that equation. Let's try another one of those. Let's see. How about y equals x squared plus 4x plus 10. I am going to change this a little bit because we know that it has to equal 0. So x squared plus 4x plus 10 has to equal 0. So we are going to get rid of the c by subtracting 10 on both sides. X squared plus 4x now equals negative 10. This is where you figure out what you have to add to both sides. That's going to make this a perfect trinomial square. So take your b and divide it by 2. So it's going to be a 4 actually. Divided by 2 gives me a 2. Then I'm going to square it. Gives me a 4. So if I add 4 to both sides, I have x plus 2, that quantity squared, equals a negative 6. Square root both sides. So something happened. Subtract 10. 4 gives me negative 6. This would not have a solution. Square both of those. I end up with x plus 2 equals plus or minus the square root of negative 6. Can we have the square root of a negative number? That is a no, so this is no solution.